Okay, today we're going to work on half angles. The idea of half angles work sort of the same way as the idea of double angles. In my opinion, half angles are a little bit harder because you have to pay more attention to where you end up, which quadrant you end up in. So, if I had the cosine of 22 degrees, or no, 22.5 degrees, that is not on the unit circle, right? But is that angle half as big as some angle that is on the unit circle? Yes. Okay. So I don't know what the cosine of 22.5 is, but I do know what the cosine of 45 is. Okay. So the cosine of theta over 2 is equal to, this is on the top right of your reference sheet, plus or minus the square root of 1 plus the cosine of theta over 2. And notice that 2 is under the square root. Okay? So what this is saying is, if you want to find an angle that you don't have, but you do have, but you know an angle that you can cut in half that is on the unit circle. So we're going to insert the cosine of 45 over here. Okay? And we need to know which quadrant are we in. Which quadrant does that lie in? 1. And the cosine in quadrant 1 is positive. So over here we have to choose between positive or negative. We choose positive. So this will be the positive square root of 1 plus, what is the cosine of 45? Root 2 over 2. Root 2 over 2 divided by 2. Okay. Well, the top needs a common denominator. So the top, this is going to turn into 2 plus root 2 over 2. So I'm going to make the 1 a 2 over 2. So I get the square root of 2 plus root 2 over 2 over 2. And now I flip and times. So I take this 2 over 1, and I flip it upside down, and I get 1 over 2. And this stuff doesn't change, but the bottom becomes 4. So I get the square root of 2 plus root 2 over 4. So can we simplify the top? No. Can I simplify the bottom? Yes. The square root of the bottom is 2. So this becomes 2 plus root 2 under the square root all over 2. That is the cosine of 22.5 degrees. Okay. Let's do another cosine. What if I had the cosine of, let's see, 5 would be 60. Oh, no, I don't want that. I want something that's in a different quadrant. So let's do the cosine of 112.5. Is 112.5 half of some angle I already know? Yes, it's half of 225. Okay, so this is going to equal plus or minus the square root of 1 plus the cosine of 225 over 2. But I have to be careful. Where is 112.5? It's in quadrant 2. And in quadrant 2, the cosine is negative. For the cosine, I don't need to worry about the double angle. Well, I mean, I get kind of. The cosine problems are easier than the sine problems, and you'll see why in just a minute. But my answer has to be negative. So I go up here and I choose the negative. Okay? Now, what is the cosine of 225? Negative root 2 over 2. So I have negative square root of 1 minus root 2 over 2 over 2. And this is exactly what we did before. I need to turn this into 2 over 2. And it's going to be the square root of 2 minus root 2 over 2 over 2. Flip and times. Yep, thank you. So negative square root of 2 minus root 2 over root 4, which is just 2. Okay? Those are cosine problems. Cosine problems are really easy because if you want a cosine, you have to use a cosine. If you want a sine, you also have to use a cosine, so that can be a little bit confusing. So let's do the sine of 22.5. Okay, the formula is almost identical. There's just a negative instead of a positive on the inside. Plus or minus the square root of 1 minus the cosine of 45 over 2. You still use cosine. Now, first, where is 22.5? In quadrant 1, is the sign positive or negative in quadrant 1? It's positive, so I'm going to choose the positive equation. And I get the square root of 1 minus root 2 over 2 over 2. And we just did that, right? What's that? How is it true? You just have to remember, well, I guess, yeah, to find the sign, you don't actually look at the sign. So in this one, it's in quadrant 1, so that one's pretty easy. But if you're in a different quadrant, you have to remember your answer is a sine, even though you use a cosine. So this would be 2 over 2, and we end up with 2 plus root 2 over 2 over 2. No. Yeah, you can just look through it and say 2 plus root 2 over the square root of 4, which is 2. Or it should be a minus, right? Okay. Let's look at let's do the sine of 157.5. Is 157.5 half as big as some angle I already know? 315. Okay, it's half of 315. So, this is going to be plus or minus the square root of 1 minus the cosine of 315 over 2. Now, where is 157.5? It's in quadrant 2. What is the sign in quadrant 2? Positive. So that's really the only trick, is the angle I want is in quadrant 2, and it's the sine value, the height. But I'm using an angle in quadrant 4, and I look at the cosine. So that's where the trick comes in. So in quadrant 4, or sorry, my answer is going to be positive. What is the cosine of 315? Root 2 over 2. So, yeah. And then it simplifies. Did they give you any? Okay, let's do number 56. sine of 75. So the sine of 75. 75 is in 1, and sine in quadrant 1 is positive. So it's going to be plus the square root of 1 minus the cosine of 150 over 2. This one's a little bit different. Right. The sine is determined by that. You look which quadrant the angle is in, and then you identify if it's sine or cosine. Right. Because if this is positive or negative, we're going to just put it in as it said. Right? This answer inside will use 150. But the final answer has to use the sine of this one. Okay. What is the cosine of 150? Go to 150. It's negative root 3 over 2. So this one's actually a little different. Cosine. So, see, I tricked you. Told you it was tricky. 1 minus negative root 3 over 2 over 2. So this becomes a plus. And then I change the 1 to 2 over 2. So I get 2 plus root 3 over 2 over 2. So it's 2 plus root 3 over 4. And when I square root that, I get 2 plus root 3 over 2. Okay? So this sine, that sine there is determined by this. And then this one will carry its own sign also, but that just influences the inside, not the outside. Well, so the cosine formula uses a negative, a positive, and the sine formula uses a negative. But the cosine of theta could be positive or negative depending on where it is. So this right here is determined by where the double angle landed. Yeah, the inside can switch. So if you're doing cosine and the angle you're looking for is in quadrant 2, then the answer is going to be negative. But on the inside, if you have an angle that's in quadrant 2, then that angle came from an angle that was in quadrant 4 or 3. No, 4. So just remember that this sign is chosen by this. And then this sign is a combination of the formula sign and this sign. Okay, let's do a tangent. 58. Tangent of 202.5. So we look at the formula. We have two of them. We can either do 1 minus cosine divided by sine or sine divided by 1 plus cosine. Okay, so let's do the first one. First off, is 202.5 half as big as some angle we already know? 405. Now, I don't like 405, so I subtract 360, and I get 45. Oh my goodness, 45. So that's the angle we're going to look at. Okay? So this angle right here is in quadrant 3, right? Now, if I double that angle, I get 405, which is in quadrant 1. But I don't want 405, so what angle also lands here? 45. So I subtract 360 and I get 45. Right. I'd rather deal with 45 than 405. And they're the same angle because they landed in the same spot. Okay. I didn't know they were moved. Huh. Yeah, maybe they just gave way. Okay. You were insane long before now. Okay. So the tangent in quadrant 3 is positive, but if you look at the formula, we don't have to worry about it. See how there's no plus or minus in the formula? So we don't need to worry about the sign. It will just take care of itself. So we look at this angle here. This is the one we're going to use to build the angle we want. And that's 45 degrees, so I get root 2 over 2 and root 2 over 2. Right? So let's do the first formula, because it doesn't really matter. 1 minus the cosine of 45 over sine of 45. So on top, I get 1 minus root 2 over 2 over root 2 over 2. What does the top need? 2 over 2. Everybody okay with that? Now I flip and times 2 over root 2. These cancel, and I get 2 minus root 2 over root 2. I have to multiply by root 2 over root 2. And the bottom turns into 2. And the top, what do I get there? Negative 2. Root 2, it's not 0. Okay, is everybody okay with that step? And now, 2 root 2 minus 2 over 2, which turns into root 2 minus 1. Okay. So let's do your secant problem, number 63. Now, there's no sense in doing these in radians. So we just need to convert to degrees. So 5 pi over 8. So we take 5/8 and we times it by 180. And we end up with 112.5. So this is number 63, the secant of 112.5. So I'm really just going to find the cosine and flip it upside down. So the cosine of 112.5. That's going to equal, first off, where is the cosine of 112.5? Second quadrant, cosine in second quadrant is negative. So it's negative square root of 1 plus the cosine of 225 over 2. And what is the cosine of 225? Negative root 2 over 2. Not yet. We'll flip it at the end. So negative square root of 1 minus root 2 over 2 over 2. So that becomes 2 over 2. So I end up with 2 minus root 2 over 2 over 2. So I get the square root of 2 minus root 2 over 4, and then I square root the 4, and I get 2. And it's negative. Nope, that's the cosine. So the secant, is negative 2 over root 2 minus root 2. I can't have square roots in the bottom. Okay? Remember how I said that half angles can be kind of nasty? So I need to multiply by, yes, it is that hard. Okay. It is a long process. So do you understand why did I do that step? That gets rid of the first square root. Yes. This is a hard problem. Okay. So does everybody understand why I did this? This will get rid of the big square root. And it leaves a nasty answer. So negative 2 square root of 2 minus root 2 over 2 minus root 2. Kind of. Say that again, Nate. No. So if you have a single square root, you get rid of it by timesing it by itself. But this is not a single square root. It's 2 minus a square root. Conjugate. Yep. Now, before we go too much further, somebody flip to the back on 63. And we'll see, did Cynthia... Oh, she didn't rationalize it? Oh, how wonderful. Cynthia, we take back some of those things we've been saying about you all year. She did not rationalize. So I'm not going to make you rationalize. Nope. Okay. I want you to stop at 65 today. So I hope you make it that far. So stop at 65. Oh, good. Okay, get to work.